Hello there, friends. We are doing some more statistics today. Today we're going to talk about variation within a data set. And when we did lesson 1, we talked about standard deviation. And there were two types of standard deviation. There was population standard deviation and the sample standard deviation. We will focus on the sample standard deviation, but standard deviation tells us the um, variability, the variation of numbers that are within the data set. Now, our measures of central tendency, that's the mean, the median, and the mode, those give us numbers that describe the typical data value in a given set. So mean, median, modes are used to describe what most of the numbers are close to. They don't let us know how much variety there is in the data set. And variety is important to know about because we need to know how spread out the scores are. Are they mostly the same around that one mean, median, or mode? Are they mostly the same around the mean, or are they really spread out around the mean? And that's important to know about how the scores lay out in your data set, especially if you're talking about things like test scores. If your mean was an 85, sounds like that's not too bad. But if they spread out from like a 0 to a 90, it's important to know what happens at the low end. So we have things like the range, the interquartile range, and then what we're going to focus on today is our standard deviation that tell us what the variety is like within our data set. So we have two data sets given below. They have equal means, but they differ in the variation within the data set. We're going to use the calculator to determine the interquartile range of each of the data sets. Now the IQR, if you remember correctly, interquartile range, that's when we do our Q3 value minus the Q1 value to get our interquartile range. So if you have your calculator, you can put these into the calculator in the lists and go through to get all your data information so we can find the Q3 and the Q1. Now I did that for you if you want to just save time. I have it right here. So in my list that I named W, that is data set number 1. So if I scroll down with my data set number 1, I can see that my Q3 is 9.5 and my Q1 is 4.5. All right, so back over to here for data set number 1. Q3 was 9.5 minus Q1 of 4.5 gives us an interquartile range of 5. Back over to my calculator. If I scroll over a little bit, here's data set number 2 and list K. I named it K. And our Q3 is 8 and the Q1 is 6. So I will do Q3 minus Q1, which is 8 minus 6. So this is a spread of 2. Now the interquartile range gives a good measure of how spread out the data is, but the best measure of variation within a data set would be the standard deviation. What the interquartile range is telling us is that half the scores are within 5 points of each other. And then for data set number 2, half the scores are within 2 points of each other. So that's a much less variety, much less spread out because they're closer together. More scores are closer together. Now, standard deviation gives us a better idea about the variation of values within a data set. Standard deviation is a calculation that shows us how far each data point is away from the mean. So it's basically like an average of the distance each data point is away from our average score. So if you take all your points, add them up by the number of scores, that's your mean. The standard deviation tells us the average distance, how far each data score is away from that mean. So it's like an average of distances from the middle value of the mean. Okay, so we have, or I have, all that data put into the calculator. So let's go back to my list W. That's data set number 1, and let's look at our standard deviation and our mean. So our standard deviation, the sample standard deviation, is the S of X. So for this particular data set, it's 2.7386. 2.73861. And then if you click on it, you can see how it shows more of the decimal. So back over here, use the graphing calculator to determine standard deviation data set number one. We did that. So for data set number one, our sample standard deviation was 2.738. For data set number two, scooch over a little bit. Column K is data set number two. Standard deviation, I look for the SX. That's the sample standard deviation. That's what we use unless they tell us population standard deviation, which is the one underneath that. We will use the sample standard deviation, which is 1.4907. So over here for data set number two, it was 1.4907. What does this say about data set number one versus data set number two? What this tells us, data set number one has a higher variability. That means that more scores are further from the mean. So data set number one has a higher variability because it has a higher standard deviation. That means more scores are further away from the mean. They're more spread out. So data set number one is more or has a higher spread. All right, that's what it means. Standard deviation is basically telling you whether most of your scores are close to the mean or whether they're spread out more. So if you think about a large standard deviation, think about a dartboard, kind of give you a visual. A large standard deviation means your data is widely spread away from the mean. So if you add up all the scores, divide by the number of scores, you get your mean, your average, what you're used to saying average. If you have a high standard deviation, that means those other data points are really spread out far away from your mean. So they're not clustered, they're more spread. The smaller the standard deviation, the more clustered the data set is around your average, around your mean. So high standard deviation, high spread, high variability. Low standard deviation, low spread, low variability. And low variability, low spread means your data clumped closer together, more clustered. Okay, so let's take a look at a study measuring the lifetime of the various brands of batteries. The following is a dot plot for the lifetime hours of two different battery types. So we have brand A battery and brand B battery. Which brand has a greater mean battery life? And we should be able to do this without going to the calculator. So you look at your data set. Which brand would you predict to have a higher average battery life, a higher mean? Well, we're going to say brand B. How come? Simply put, has larger numbers. We got brand B, 115, 119, 112, 98, 106. They are more consistently higher numbers than brand A. Which brand shows a greater variability? Which one shows more spread out of battery life hours? That would be dun, 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 brand A. And because the battery life hours, the hours, they're more spread out for brand A. Which brand would you expect to have the greater deviations from the mean? So which one would you expect to have greater deviations from the mean? In other words, which one would you guess would have a higher standard deviation? That would be also asking like which one, well, you would get the answer by looking at which one's more spread out. So variation or deviation from the mean is talking about which one's more spread out. So that's brand A. Now, when they say ignoring the signs of deviations, that means ignore whether it's above or below the mean, just whether it's spread out or not. Okay, so now we're going to calculate the mean for each battery brand. So you're going to go to your calculator. You're going to type in into the table 82, 94, 96, 113, 120, and do all the statistics stuff that we started on Unit 1 that I showed you how to do in person on the calculator. If you don't have a calculator, sit tight and I'll get you the information. If you have your calculator, you should be entering the data now. So for brand A, our mean was 101 hours, and our sample standard deviation was 15.3297. So what does that mean? Well, that means on average, our data points are 15 hours away from the mean of 101 hours. What about brand B? So brand B has an average of 110-hour life and a sample standard deviation of 8.2158. Smaller standard deviation means it is less spread out, which is exactly what we were talking about in some of the above questions. Brand B has a greater average, which we see. Brand A is more spread out, which means it has a larger standard deviation. And that calculations that we just did confirms what we were looking at the graph. The one that's more spread out will have a higher standard deviation. So how would you interpret the standard deviations that you found? Well, brand A batteries have more variability. Brand A batteries have more variability of lifetime hours. Brand A has a higher standard deviation, therefore brand A has a higher variability in lifetime battery hours. That means they are less consistent as far as how long the batteries will last. Because the battery hours are more spread out, they are less reliable to predict when those batteries will die. Okay, that's kind of the idea behind the standard deviation to tell you the spread of the scores, to tell you whether it's likely to happen or not likely to happen based on how far those data points are away from the mean. So because brand A has a higher standard deviation, that means less consistency as far as how long the batteries last, because the data shows hours, battery life hours that are more spread out. That means brand B is going to be more consistent because it has a lower standard deviation and a lower spread of scores. Now, it doesn't mean that it has a higher average, even though in this case it does. It just means that it's more consistent. The battery life hours seem to all be close to the same length of time for brand B. All right, one more example, and then I'm going to cut you loose to do some practice on your own. The data set gives the points scored in each game played by the boys and the girls basketball teams this season. That's not really true data for Penfield, but that's what the context of the question is talking about. So for the boys team, they had games 56 points, 81 points, 80 points, 75, 48, 65, 90, 66, 70, 70. For the girls, 76, 60, 72, 61, 58, 78, 65, 66, 55, 65, 73. Calculate the standard deviation for both teams. So I'm going to go over my calculator. We'll do this together. I want to get okay. Gonna get a new spreadsheet set up, and I'll label this one um, boys for the boys. Oops, no, wrong table. Up here. There we go. So our boys score 56 points, 81, 80, 75, 48, 65, 90. Good game there. 60, 66, 70, 70. And I'm going to check my list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in our list, 10 numbers in my list. So I counted the numbers on the paper to make sure it matched the numbers that I have in my list. And I have 10 of each, and that's what I'm supposed to have, so that works out good. All right, for the girls team, we have a 60-point game, a 72-point game, 61, 58, 78, 65, 66, 55, 65, 73. All right, so now it asks us to calculate the standard deviation for both teams. So menu 4, 1, 1, enter. I want to calculate the standard deviation for both the boys team and the girls team, and I'm going to put my data in list. I guess C would have been fine. Okay, so here's the calculations for the boys games, and I need to scroll until I find our sample standard deviation of 12.328. 12.3238. So back over to here, finally, for our boys, our standard deviation was 12.3238. All right, and now we're going to do it for the girls. So back over here, menu 411, enter. And this is, I need list girl, enter. There we go. Standard deviation for the girls is 7.2426. So this doesn't tell us which one's higher scores or lower scores. It tells us which one's more spread out, who's more consistent. So interpret the data as to which team is more consistent in their scoring. So which team scores almost always the same, or their average score, they stay very close to their average score. So less variability, more consistency, and that would be the girls. Girls team has a lower standard deviation, so their scores are more consistent. More often the same. Okay, that means they have less variability and more consistency. Okay, so that's it for standard deviation. What I want you to do is turn the page, go do some practice problems, and then you can use the answer key that's in Teams to check your work, make sure you're doing things okay, and then I will see you soon. All right? Thank you for your time and patience, and take care of yourself. Goodbye.